Hello everybody, today I will be showing you how to code in Vivado. So we're going to start with just opening the program, and we're starting from the beginning because I'll be using the web package for Vivado, and depending on what package you're using, there are many things you can and can't do. So we're just going to go to quick start and hit create project. And then just click through this for a while. You can decide where you want to put it. I just put it in a temporary file until I need to export it. And you're going to want to use an RTL project. And I choose do not specify sources at this time because the sources are very important, and you're going to make sure you know what sources you need. Oftentimes I end up making, you can see here that I've made lots of variations of the same project because of source errors. So we're going to just not specify it at this time. And next you're going to want to choose your Basis 3 board. On the package it comes with, it should say which one you need, and you just have to select it through here. In this case we'll be using the XC7A35T 3060. So we just select all of this, and then this is the one that is equivalent to mine. It's not exactly the same, but it'll work for what we're doing. So now what we're going to do is add sources, and for this part you're going to want to select add or create design sources. And the reason why we didn't add sources before is because it would make us go through the constraints, the design sources, and the simulation sources. We will be using both constraint and design sources, but we will not be using simulation sources. So we'll just go through there, and we're going to hit create file, and we will be coding in VHDL. For file name, I'll go with module 1. Alright, and then hit finish. Alright, and so this, you'll be adding all of your input and output variables. So let's just go with A, B, C, D, E for the inputs, and then X, Y, Z for the outputs. Let's remove that extra one, and you'll have to specify each one as output, and the default is input. And you'll also notice here that there is an option to do in and out. I'll get to that a bit later, but you actually can't, even though it gives you the option to specify it as an input, both an input and an output, you can't. I don't know why they include the option in this drop down, but we'll just have to deal with it. So we'll hit OK there. Let it think for a bit. Alright, and then double click on this, and now you can see it automatically just lays out all of your sources here, and gives you a nice template to work with. So I'll start with how you can create both an input and an output source, since you can't do it when you're directly adding the sources. So what you're actually going to do is you're going to put in signal, and then the name of the source, like x1 colon std logic. And so basically what this says is x1 can be used both as an input and an output. And that's extremely important to know. These are very useful for intermediate connections between gates, and yeah, these are very important, and you will have to use them when you get into more complicated designs. Alright, so for the next step, let's add our constraint file. We'll right click there, click add sources, and then add or create constraints. And for the constraint file, you actually won't be creating the file. You will want to download the XDC for your Basis 3 board. So I already have it downloaded, and you can find that download just on the Digilant website for whichever board you're using. So it's usually called Basis 3 Master. Alright, and let's see what that looks like. So you'll notice that almost everything here is commented out. Basically what this file is used for is communicating your module code over to the actual hardware, the Basis 3 board. And so it's pretty straightforward on how this works. On your Basis 3 board, each LED and switch will be labeled with a letter and two numbers, like U16, E19, and then that corresponds with this variable. And so what you're going to do is change these variables to your output. So actually, let's put in some code here first before we get to that. Some very basic stuff will be X is A and B. And so this is just saying X equals 1 when A and B equal 1. So we'll go over here, and what you're going to do is instead of LED 0, we're going to put in X, and you have to do it for both of these. Oh, and by the way, to comment out or uncomment, what you're going to do is hold Control dash to remove these variables. Now let's add our inputs in. Let's use the switches, not the buttons. If I can find it, here it is. So I'll just put in 4 inputs because why not? Alright, so I cut that part out, but we can just, we'll use this. And then make sure you save your file for both of them. And alright, so now we've got the code. If we have A and B on, X should be 1 and it will light up. LED pin U16. Okay, great. Now how do we actually make this work? So we're going to start, usually this isn't very complicated, but when you have more complicated code, you're going to want to diagnose it because actually getting it onto the board is a time-consuming process. So we're going to start with running simulation. And basically what this will do for us is we can just test if our code works the way we want it to work. Alright, and so when you're in your simulation, what you want to do is you right click on your inputs, click force constant, and you can choose 1 or 0. For this case, we'll choose 1. And you can also choose when it activates, so let's just have this one activate 5 nanoseconds later, because why not? And then run simulation, and it always starts you zoomed in quite a bit, so let's just, there we go. Alright, so as you can see, A switches from unknown to 1, and then B switches from unknown to 1 a little bit thereafter. And then X only switches from unknown to 1 once both of them equal 1. So it looks like everything should be working as they should be. Obviously, we haven't gotten into anything complicated yet, but this can be very useful in diagnosing problems. So next you're going to come over to RTL analysis and click on that. Okay. And what this will do for you is generate a schematic. If you're ever writing a report for your project or coding program, this screen that's going to come up is going to be pretty useful in showing. It generates exactly the schematic of what circuit you're building through the code. We'll ignore that. So again, very basic here. It's just sending A and B through an AND gate with an output of X. So, alright, we got this far. I think we're ready to move it over to our actual board. And this is the long part. What you're supposed to do is go to run synthesis, let that load, run implementation, let that load, and then generate bitstream. Well, actually I found it. If you just click generate bitstream, it does all of that automatically. So, and it takes just a couple of minutes for everything to load. So alright, and now that the bitstream generation is completed, you'll actually ignore this screen, hit cancel, and what you're going to do is to connect your board to your computer and actually transfer it fully, plug in your Basis 3 board, turn it on, hit open target, auto connect. I already did this, so that's why it's not showing up, but auto connect, it'll load for a bit, and then program device, select this one, program, and now our code should be working on the board, and it looks like it is. So that concludes everything for this tutorial. There's a lot you can do in VHDL, but the Vivado software itself on its own is pretty tricky to work with, so hopefully this tutorial helps someone out with their project or whatever they have been doing. Again, this is only for the web package edition, because every package will change what you can and can't do. So thank you for watching, and that's it.